Hello everyone, today we'll talk about the solution to the problem minimum number of operations to move all balls to each box. While I don't think that the solution to this problem is too difficult, there are some general patterns that we can use to come up with that solution, and so if it's not intuitive to you, maybe hearing about those general patterns will help you, so that's why I'm going to focus on them. If this problem is obvious to you, then great, just solve it and that's it. But when it comes to general patterns, first of all we see that this asks us to generate a list with answers independently for every position. So if we want to solve a problem like this, we either want to pre-calculate something such that calculating the answer for any position we want is fast, or at least we should be calculating answers one by one in such a way that we can use the state of our calculations when calculating one answer to quickly calculate the answer for another position by updating our state quickly without too many operations. And this is what we're going to be using here, and that's a very general idea. And another thing is that the answer for every position, well, let's think about what that answer is. We have to move every ball to that position, so every ball to the left of the position will have to be moved to the right. Every ball to the right of our position will have to be moved to the left. And in fact, when we have a ball that's away from our position, we have to move it by exactly the distance between those two positions. So we have something that can be seen as a nested sum. This is a sum for every ball to the left, let's say, of the distance. So the sum for every ball to the left, the sum over every position between that ball and our current ball of just 1. That would be the sum. And whenever we have a sum, it's good to think about, for instance, changing the order of operations, or just doing essentially whatever we want to do with the sum to make calculating it easier. And while here we're not going to be messing around with the order of operations, we can simply notice that if we have calculated that sum for some position, and we move to the position that's 1 to the right of it, then for every ball that was to the left of our previous position, and also maybe that ball on that previous position, if that previous position had a ball, the distance will increase by 1. So instead of calculating again for every ball the distance and summing it up, we know that for every ball the distance will increase by 1, so the total distance will increase by the number of balls. So what do we need to do to solve this problem finally? We have to maintain the count of balls to the left and to the right of our position, and also start by calculating that sum, because we know how to update that sum based on the count, but we have to know the starting value of the sum. So at first, everything is to the right, so the sum of the position for every position where the character is 1. Of course, the count of ones is just the count of ones. And also, since we are imagining that we are starting to the left of the whole string, we add the count of elements to the right immediately to the sum of the elements to the right. Sum and count of the elements to the left is of course 0, there is nothing to the left of us. And now for every position, we have moved 1 step to the right, so the sum for elements to the right decreases by their count. For every element to the right, we move 1 closer, so in total we move right count closer. Again, we move away from elements to the left of us, so that sum increases by the count of elements to the left of us. And now, if this position has a ball, we have to update the counts. Now that ball is no longer to the right, but it's now to the left. We can think about this right and left, not maybe exactly as right and left, but right is what balls are we going to move closer to in the next step, and left is all the balls that we are going to be moving further away from. So after processing element I, we'll be moving away from the ball at position I, so that's why we have to move it to the set of left. We append to the result, of course, the right sum and the left sum, and that's it. The final result is just generated by this. And again, this first pattern that I was talking about, we can quickly update the total sum, so right sum plus left sum, by doing it. Of course, maybe it's not that necessary to think about right and left separately in this case, but I think it's easier to make sure that we understand exactly what is going on here, and that we understand where it's coming from and how to update it.